right, so we'll go ahead and get started here. And for those of you tuning in a little later, okay, go ahead. Maybe it's about this time you want to hit pause so you can put all these down here. Now, some of these will react, some of them will not. So with this, as you can see, this isn't a solid, okay? It's still dissolving because it's, what do we know about chlorides when you look on the back there? They're all soluble, but there is exceptions. Okay, so we've got some iron 3 chloride, which would be ferrous, I think, for because if it was iron 2, then it would be ferric chloride. Okay, but we have, either way you want to look at it. So this is what we call, what type of, so it's not water, so it's not a liquid. It's an aqueous solution, okay? And here we have some potassium nitrate. And what do we know about all nitrates according to your table? Yeah, there's no exceptions. So this is extremely soluble then. So if that is the case, should we see a reaction then? And we'll go ahead and put that up here as well. We said iron 3 chloride. Okay, and it's still dissolving. And we have some potassium nitrate, okay, which is also in an aqueous solution. So double replacement, and we shall see once what happens. So go ahead. And if I walk this around again, you'd see that these pieces are getting smaller and smaller and smaller just because it's still continuing to dissolve. Okay? So we said that all chlorides are soluble, but don't get hung up on this side of the equation. It also happens on this side as well. So how do we know if a chloride is insoluble? If it's bonded to what, or what?
Hydrogen? No.
Not hydrogen. Silver, lead, and mercury. That's when it would be insoluble. No.
Just the chlorine.
We're just talking about the chloride ions. So again, if you're tuning in later, remember we have these here. We have these rules. And we find chlorine or chloride. Okay, and it says it's insoluble if it's bonded to mercury, lead, or silver. So that's why with this iron 3 chloride, it's still continuing. There's still some tiny particles down in here. And then what do we know about nitrates? Are they soluble?
No.
Yes. There are no exceptions. Okay?
It's soluble.
Correct. So now, what happens if we pour one into the other? Okay? We just have, maybe you could say there's a slight color change, but nothing really dropped out of here. It's just maybe magnifying the color change that was already there, but that's not a chemical reaction. So what we could say is, yes, this is actually continuing to move forward, you might think. We could say, we could put a reaction on this side, say, well, this must be taking place, because for balancing purposes, we could say, well, we've got this iron, and then we've got nitrate. Remember, the charges will not change. Okay. So why would that tell us that we're not going to get a reaction over here? Because what do we know about nitrates? Do we have mercury, lead, or silver here? No. So that nitrate's going to remain soluble unless you have those three. Okay? Then what about chlorides then? Are they soluble or insoluble? They can be if it's bonded to what? Yes, those same things. the same three: silver, lead, and mercury. All right, because nitrates don't have any exceptions. So what we just had observed, this just remains in an aqueous state, this remains in an aqueous state as well, okay? So like I had mentioned, you might say, well, it became deeper red, okay? That might be true. The reason we say that is just pronouncing the reaction is we know, think about hemoglobin. What does hemoglobin mean to you? Blood. What is it? How do we pump or how do we carry oxygen throughout our body? Iron. So the hemoglobin is red because of iron. So you're adding this, it's becoming a deeper red red solution, is because that iron is just being expressed. It's not precipitating out because it can't. Because nitrates are too soluble. Okay? But if we were to just practice this to balance it, this, yes.
So chlorine is soluble to Ag, Pb, and Hg? Or how
No.
do you say that? What does that mean?
You can have any other metal cation, like this one or this one, and it remains soluble, unless you have that, or that one. Hg, oh, I put Hg up there. So it's mercury. Mercury is mercury, lead, and Ag. Yeah, had the A or the G correct, so we don't need to have that down twice.
So if you have silver chloride, it won't.
It would precipitate out because silver chloride is insoluble. Okay.
Chlorine is insoluble when it's bonded to Ag, Pb, and Hg.
That's correct.
So when it's insoluble, is that what makes a different type of reaction? Like,
Correct. Okay.
how do you know which one?
When you say which, are you talking about which one?
How do you know if it's solid, liquid, or gas?
Okay. Well, in this case, there's no gas coming off of here because we don't see any fumes coming out. Okay. Well, one of the things you're going to have to sometimes be given that information. Some of these we would expect that you can balance those and finish them. And that's what this other one is for. Okay? That's a little more pronounced. Okay? So what we mean by that is how would we classify? Yes, we say double replacement, but did anything fall out of there? So what does that tell you? I got to replace this marker because I don't think that shows up very well on there. Okay. Then, let's see if I have another one of those types. Well, here's a blue one. So that's probably a little more pronounced and easier to see. No reaction. All right. Nitrates. And maybe the best way to look at this is when you get to this side to see if a reaction. Like I said, it counts for both sides, okay? Nitrates are soluble, chlorides are soluble, okay? So what happens in this double replacement reaction when we get to this side? We have silver chloride and what? Sodium nitrate. Now, do we need to add any subscripts? I mean, we brought this 3 over here for a reason. Why? But why did the 3 go over there?
Because that's part of the nitrate.
Yeah, it's part of the formula for the nitrate.
The silver chloride isn't going to be oxidized.
Okay? So,
Silver goes into solid.
right, so what that means then is, are nitrates soluble? And are there any exceptions? So that's going to be aqueous. Okay? Now, don't get ahead of yourself. Are chlorides soluble? Yes. But because silver is bonded to that chlorine, so that will precipitate out.
Because that's on the periodic table.
Okay? Well, like I said, chances are if it's a gas, that's something that you're going to see come out of the solution. Because what happens is you're going to see either well, you can't see carbon dioxide. You can just see bubbling. That's a gas. You know that is a reaction. You certainly know if you're diluting acids, hydrogen gas comes out of there because you can see that. And that's something that we can illustrate tomorrow. Yes?
I mean, like, when we're just doing them on paper, not, like, actually putting the
Oh,
elements
okay.
How do we know on if we just had the problems, not, like,
Oh, okay. So that we could say something like this. If we had some hydrochloric acid, okay, and that is going to be in an aqueous state, okay, then we're going to add some a metal.
How did you know that was an aqueous state?
He has to tell us that.
I'd have to tell you that, yes.
Can
Okay.
we not just, like, show this with one of the problems that are already up there? Or do we just write out of it?
But you wanted to see one that was a gas, so that's what we're doing.
No, but how do you know, like, how do you know, though? How do you know, like, on paper,
Oh.
that it's gonna be a solid or a gas?
I'm trying to show you that.
Well, you just showed us a solid one, like, we're wondering how you
And
knew.
I'm trying to show you another reaction that you know takes place because it's a gas that's given off. Are we not communicating here? Where's the disconnect happening here?
Just show us and then we'll go from there.
Okay. So then I need a metal. Okay? Is it ferrous or ferric? Okay? That means eventually, not yet, but on this side, it's going to do that. Okay? It's a charge. Because right now, what does it have for a charge? Okay? So now, what type of reaction does this look like? Okay? Now, you're going to say, how do we know that's a solid state? Well, what's the major component of steel? Is steel a solid? I would say so. So that's why we're putting an S here. Okay? So then once we add that to this side in our single replacement reaction, okay, what is going to happen on this side? Okay, so now we've got our replacement of iron will replace the hydrogen, but this is why that 3 was important. Okay? There's 3 chlorines here. And then what is left over then? Okay?
Why were there 3 chlorines?
To match the charge of the iron, because iron is plus 3.
Mm-hmm.
Oh, yeah, okay.
Okay? So then, are we sure that this reaction would take place? Where's hydrogen at? Hydrogen's below iron. So we know this is going to take place. Okay? So then what's going to happen is are chlorides soluble? Is this silver, mercury, or lead? So what type of solution is that? It's an aqueous solution. And what type of state is this? Because you're forming a gas. So you know that that reaction is going to take place. 1, because of the activity series, and 2, you are emitting a gas, which is a reaction. Are we on Saturn or Jupiter or no? No. The pressure is so enormous that you'd have to liquefy that's just not going to happen.
It'd have to be really cold or really high pressure.
Correct. You'd have to make that extremely, extremely, extremely cold. Okay, now, does this answer your question about something other than an aqueous solution? Okay, and that's fine.
Can you go over what the ferrous and another thing you said were?
Well, no, it's because what's the symbol for iron? Fe. And all I asked, this is the only thing I said, was ferrous or ferric. So he had said ferric. So that means that's a +3. We would have to tell you that information. I don't expect you to know ferrous sulfate is FeSO4 as opposed to ferric sulfate, which is Fe2SO4 3. You know, I don't expect you to know that. We just wanted you to make a choice, and we did. Okay. Can we erase this? Get this thing away from me, just like evaluations, right? Okay. So we can get rid of this. Okay. Now, so we know that this reaction will proceed because this precipitates out. Okay. Are nitrates soluble, whether it's on this side or this side? It makes no difference what that nitrate is bonded to. It's going to dissolve because nitrates are soluble. What about iodides? Well, it must be soluble here because we put AQ. Unless silver, lead, or mercury. So now, as we proceed in this reaction or try to complete that, are there any one of these subscripts that are going over here for sure? The 3 will, yes. This 3 has to come over here because it's part of the formula. Okay? Just like this one here. All right. So what does the lead bond to but on this side if this is going to react? Okay? And then we'll come back to that. And what does the potassium bond to? Okay. What do we know about nitrates? This is going to be an aqueous solution. Okay? And then is this compound balanced? Need 2 of these. Okay. So, in this reaction, what we're illustrating here, okay, we've got some lead nitrate. Okay. Now, that's just because we put in more of the powder than if we put more and more water in here, this would totally dissolve because there's quite a bit in here before we started. Okay. Then we've got some potassium iodide then as well. Is iodides soluble? Yes. Unless.
Not with lead.
Okay. So then what happens if we pour these 2 together? This is where you go dun dun dun. Oh, okay, drum roll, not dumb roll, drum roll. Or if you want to go dum dum dum. So then what do we see happening? Is that a chemical reaction? It is. Now, you're going to say, well, something like that happened over here as well. Yes, that's true. And even if we leave this over here for even overnight, okay, nothing's going to change in that solution. Okay? But now, we'll just leave this here for a few moments, and you're going to see 2 layers start to form here. Because what does this tell you? We already know that this is an aqueous solution because nitrates are soluble. But what does it say about iodides? They are soluble or insoluble? They're soluble except, and we've got lead there. Okay, or silver, or mercury. So we'll just leave this set here, okay, and then we will go ahead and proceed. So now, to finish this, what are we putting here? solid because it had precipitated out according to your chart here. It should say, and it does, that this will precipitate out because leads are insoluble. Okay. Then I didn't even check to see, well, this one's balanced just by looking at it. How would we know that? Because the -1 ions were bonded to +1 ions, so this is a balanced chemical reaction. Then when we look at this one, we've got 2 nitrates as opposed to 1. So what do we have to do here? And then here, then we could proceed. Okay. And then, now, let's look. Do we even need to finish this one? What's true about nitrates?
Always soluble.
Okay, so what would this nitrate bond to from this compound but on this side? Okay, so therefore we know that we've got some magnesium nitrate. And it's going to be an aqueous solution because nitrates are soluble and there are no exceptions. What does sodium bond to? Okay, it's going to bond to the chloride. Is that soluble? Of course. And that's AQ for those of you tuning in a little later. Okay? Only for balancing purposes. Otherwise we would say no reaction because nothing's going to change here. It's all aqueous. All you have is just 2 liquids being mixed together. And that's it. Okay, you can kind of see that it's separating just a very fraction of a little bit. Okay. Front row, are we on the bus here? Back row, are we on the bus? Okay, so we see some of this, and some of this, okay? But that's why we had discussed that to begin with. Think of that first time that you were serving a volleyball like this or shooting a free throw. It sometimes takes a little bit of practice till we get a little better. Yes, ma'am?
So the last section, no reaction?
Correct, because nothing changed. They're both soluble. Unlike this one where we had an insoluble product that fell out or precipitated out. It fell out of the solution.
Any compounds of nitrogen, are they all aqueous?
Nitrates, not nitrogen. Okay? It doesn't matter what you mix with a nitrate. It's going to be soluble. AQ just means you've taken a substance and mixed it with water. Now you have these types of ions that are in the water making an aqueous solution. Okay? Because we do have liquids then as well, and an example of that would be something like this. Okay. Methane. What is that? That's a gas. Okay? So oxygen is what? Okay? So what type of reaction does this look like? We've got a hydrocarbon combining with oxygen. It is a combustion reaction. Okay? So then what is produced in all combustion reactions? So then we don't have an aqueous solution over here. We've got a gas and a liquid. Water's a liquid, plain and simple. I think everyone could agree with that, correct? Maybe not on Mars, I don't know. Okay. Okay. Well, that took a little longer than what I thought, and that's okay. That's how we learn. Okay? So, we will discuss this activity that I have in mind for tomorrow. And this is what we had up on the board yesterday. Okay? In other words, if we have this, what would you put after that? It's aqueous because nitrates are soluble. Okay? Then if we were to add some of this, so then what type of letter would we put after the Cu? Because it's a solid. Okay? So then, is this reaction going to proceed?
Wait, yeah.
Well, I heard no and I heard yes.
Silver's less. Yeah, silver's less.
So in other words, this is above the silver. So this will replace the silver, but on this side. So therefore, we have copper nitrate, which will be an aqueous solution because all nitrates are. Okay? And then what should happen, okay, and that's a solid, okay, that's where we had something like this, and then we drew that on there. The chemistry, yes. Oops, that was supposed to be a triangle. There we go. All right. To what extent we would do these, and I really can't answer that because I really don't know. We'll find that out tomorrow. Okay. So, there's nothing about this that is easy. It's just not. Think about when, okay, oh my gosh, volleyball, we got to go play Chester. There's nothing about that that is easy, is there? Okay? You are going to go to a tryout with other schools that are auditioning for All-State. If they're doing that All-State course, chances are they're probably pretty good too. It's difficult. That's just the way it is. Okay? It's hard. But the more we practice, the more we keep using this type of vocabulary, the better we get at it. Okay, we'll catch up to you next time.